Welcome to our third video in this orientation to structured process improvement. Now we're going to talk about discipline in performing routine work. So we've talked about the idea of quality and what processes are, and now we're going to focus on this idea of doing the routine work of the organization. Now, how do measures help us to manage better? We focused on the need for measurement systems. And I think this quote by Esther Duflo, who was a Nobel laureate and has done a lot of work in artificial intelligence, she said the greatest source of ineffectiveness is often not in biases, corruption, or ill will, but in the three I's. Intuition. I think it's doing this. Ignorance. I don't know what it's doing, but I'm guessing. And inertia. We'll always do what we've always done. And so what we see is we have to take a fresh perspective and understand, discover what are the measurements actually telling us, and look at things from a different perspective than what we have in the past. So we have to see things in a different way. So there's four discussion topics that we have. We'll start talking about standard work and process management, the benefits of working in a disciplined way, the prerequisites for disciplined work performance, and how self-inspection is a responsibility of workers. So let's begin. What are these ideas, standard work and process management? So standard work is basically the best way we have seen to do something. It's an accepted best practice to produce the quality outputs from work processes that we desire to have. So typically it's seen as a checklist of steps or a flow diagram that shows the process sequence, and continual streamlining of standard work results in this efficiency, less cost, higher throughput activity, and higher quality. So this is going to be very critical, standard work. It defines, if you will, the settled point, and say we say this is settled knowledge about the best way to do the process. Now that doesn't mean it is not up to change. It's always up to improvement as we discover new ways to do things. And part of the idea behind continual improvement is that we keep challenging ourselves to find better ways to improve the measured performance of each process. And this is where process management comes in. So where standard work could be seen as static, when it's combined with process management, we see there's a structured approach to evaluate the effectiveness, efficiency, and economics of the standard work. And this is involving standardizing the tasks, the measurement systems, and so forth, and making sure that these tasks are evaluated and tested by the workers to assure completeness and quality in their tasks, and that we have found the best way of doing things. So if we take a look at this, we typically see that it takes at least 3 cycles of learning to get this understanding of what is standard work. And the first time we do this, we follow this cycle, which we'll talk about in another module. It's Standardized, Do, Check, Act, or SDCA. But the first time we do it, we just understand the process. So the first cycle is gaining some understanding of what's there, what we're doing, and we're not really getting this best way observed. We're just observing what is our way of doing things. And so this is what you might call a Gemba walk, or management by walking around or wandering around, however you want to call it. And the idea is we go to where the work is being done and observe what's happening, talk with the workers, and find out what are they doing. Now, after we've done that, then we can go back and we have this understanding of the flow and the work at each station. We can do a second iteration of this particular SDCA process. And here we move from understand to document. And at this point in stage, we should be able to start documenting our process flows, the measurements, how we actually do things, what are the checklists, do we have a common checklist? And we start seeing where is the variety of things going on. So we can start establishing clarity of communications about the work that we're doing, about the work methods, the sequence of the work, as well as the requirements for performing it. The third time we do this, we can actually go through a process that says simplify. And this third process is basically what many of us call Kaizen, or a lean activity. And this is actually saying, what can we do to eliminate lags in the process, time sequences where we have delays, things are not operating in any speed, but they're idling. We have leaks, if you will, material leakage or profit leakage happening, and friction because we don't have good collaboration across the people in the process. And these create losses in productivity due to quality, inefficiency, and cost problems. So at least 3 cycles of going through this is necessary to start building up a structured system of work standards that enables us to actually have long-term performance of the process. Now, what we see is there is discipline in doing the work. And so we see there's 5 different things. We have to manage the flow of the inputs. We have to evaluate the quality of the inputs. We have to perform the work in the process consistently and evaluate the work quality and ensure we get the quality outputs. So how do we assure the definition of standard work? Well, we have checklists, written procedures, standard tests, training courses, job aids. All of these must be developed and kept in line with what the process needs to do. Regularity in work performances is assured by managing the flow or the cadence of the incoming work, how we set up the jobs coming to the work, how we do the sequencing of those jobs so we can have maximized efficiency. And then how do we balance a distribution of tasks evenly, this is called line balancing or workload balancing, across the operators. So we don't have any one operator overburdened with tasks to perform in the fixed time that the cycle should be operating. And then we measure the work to ensure that this consistency is maintained over time. So discipline comes from regularity. It comes from cadence, sequencing, and balancing the production activities. Now, measurements actually document the standard work. As Dr. Joseph M. Juran, the quality guru of the 1960s and 70s and 80s, said, without a standard, there can be no improvement. We have to know what's the foundation from our starting point. So this is the baseline. So the standard begins. Now, when we have a standard, we shouldn't necessarily set it so high that it's perfection right away. What we need to do is set the standard so it's lenient enough to allow us to improve it and to build a habit of making constant improvement to the process, using experiments to test what can we do better. And this is if you will, cycles of experience that are built into that UDSO process that we started talking about. And we need to understand the observational components. So the measurement is an objective observation of performance. And it's composed of a device that's making the measurements, the observer who's collecting the data, a procedure to gather it and sample it, sort it, collate it, and store it. And then the measure itself includes both signal, what we want to measure, and noise, the unwanted components. And so when we're looking at this, noise is something that is uncontrollable. It's an unwanted part of the measurement that is, if you will, degrading the actual understanding of what we're achieving for good. So what we're looking at in a process is basically a signal to noise ratio that's high. So we see the goodness, and the measurement of the goodness is outweighing the badness. Traditionally in measurement systems, we want to see less than 10% noise levels in the process to make sure we have an adequate understanding of what the performance is. As we get into digitized work, this becomes no longer a problem. And we have an analyzed world with operators or people doing the measurements, we can start seeing that we have more errors coming in because of the variation in the way people take the measures, and that distorts our understanding of the process. So we have a measure. What can we learn from the measure? Well, basically, choosing a measure itself, we can understand what do we mean by goodness. So if I tell you the measure is profit, what do you want to do? Have high or low profit or average profit? I think high profit is what most executives would say. You know, when we talk about goodness, about productivity, do we want to have intermittent productivity, constant productivity at a high level, or constant productivity at a low level? I think constantly high. Also, we can tell the operating range. We look at the history of that measure. We say, where was it high? Where was it low? We can see what are the limits of the performance of that measure. What is the effective range where it's actually doing well outside the boundary conditions of specifications? Or how does it degrade as we reach the limits of those limits of the specification? We can see also the measurement over time. What does the statistical distribution look like? And this can give us some idea of the estimations that can be made about the probability of performance. And we can also see what sort of patterns of change happen. If one variable is changing and another one changes in the same direction, are they collinear or are they causally related, that one is a cause of the other? And we can start understanding more about those trends in performance and then what is happening to shifts in level of outcome as a result. And this is how we build in the concept of causality and understand how to build the ingredients of a successful change project by saying when we find those input variables that change the output variable, those are the ones that we want to put in a state of control so we drive the output performance to the desired level. So if I take a look at data and I see I've got data that looks like this, the green line, the thin green line in the middle is the average, and then the upper and lower red lines are the basically the upper and lower observation points, statistically speaking, plus or minus 3 standard deviations. And so we have unusually low probability and unusually high probability. But most of the data we see here is centered around the mean. It's in that green band. As we get further away from that, we see less data happening, and we see that yellow band, and that's the low signal to noise. So the natural process limits, the green part, would be what we could say we would be able to produce from this process on a regularly repeating basis. But it's not everything that comes out. And not everything is going to be within that boundary condition. So how can we improve and get rid of some of those things either in the upper or the lower areas of those signal to noise ratios that are not acceptable? So measurement uncertainty increases as measurements get close to the limits of the measurement device detection capability. Another thing we see is the closer observations are to the limit, the more affected they are by noise. And we start seeing this signal to noise ratio becoming more important. Beyond the limits of device performance, the only observations made are based on probability, because we haven't seen enough data to be actually make a firm judgment or draw a conclusion about what the performance is actually doing. So stable measurements make better estimates of performance and can be made with higher probability. Well, that led us, when we started taking a look at how do we build methodologies around this, in the 1920s to create the control chart. But because measurement systems were so poor that they were always using sets of measures based on averages. And as we've found as time passed on in the 1990s, those measurement systems are no longer the best. And what we see is that we can actually do better with individual measures because the amount of noise has decreased, because measurement systems have gone digital. And we can have a variety of measurement systems that are reinforcing each other and giving us better understanding of process performance. And so old methods that were created and that were valid in the 1950s and 60s and 70s and 80s no longer are the best methods to use today. And so we have to think, how can we use this instantaneous data collection systems? How can we use probability calculations and so forth to our advantage in terms of managing processes and improving performance? So the benefits we get out of working in a disciplined way is we can have harmony, we can get smoother flows, which gives us better consensus about what our work is and aligned cooperation, improved teamwork, and we have less friction in their way of working. So we have agreement between shifts and people about how to do the job. We also can eliminate hazardous conditions and have improved safety. And we establish the best way of working so that the results are stable and we get the best quality performance out of the process as well. So there are some prerequisites for performing standard work. The first is we have to know the requirements. What is it that we're expected to produce? Second, we have to know the equipment and materials. What do we need to make the production happen the right way? Which material is the best to use for the particular choice we have in the application? We have to have instructions. People need to know what to do in what order and then how to evaluate the quality of that work. Then they have to be trained so they can do it in a proper way and get the tasks right. Then we have to set realistic targets that can be completed on time and to the level of both delivery requirements and quality requirements within the constraints of the safety of the operators. And basically, these are the fundamental elements that we would see in standard work. Now, Aiming to get it right the first time is basically about quality, persistent pursuit of goodness, coupled tightly with relentless avoidance of badness. So, how do you know if what you're doing is good? Well, that means we have to have a measurement system. Everyone has a responsibility to deliver and inspect the quality of their own work. So this is the first requirement. Each of us had to see, what are we doing and are we doing it the right way? If a mistake happens, we have to take action necessary to correct the mistake, prevent its recurrence, and apply countermeasures to keep it from happening again. And this is how we ensure harmony in workflows by eliminating process upsets. So every detected mistakes that we have in the process is an opportunity for Kaizen, or improving work for better performance. And this identification and implementation of countermeasures can occur at that particular point. So, team discussion. Take a look at these prerequisites and the reasoning that goes with them. What aspects of your daily work would benefit if they were defined in a standardized way by looking at each of these to see, are we actually able to repeatedly do things we need to at the level of goodness and avoiding the mistakes that could be made in that process? So here's just a worksheet that you can use for filling this out. The second column would be, what is the meaning of that standard work in your particular environment? And the third column would be, provide an example from the work that you're doing so that you can see what could be standardized in the future. So I hope you enjoyed the exercise, and thank you very much for watching this video.